Okay, so here I'm going to try to prove that the VR component of V is equals to square root of mu p times E sine f, and that V theta or V sine gamma is equals to square root of mu p times E plus cosine of gamma. Now, what I want to start from is H, the angular momentum, is equals to R cross V, or it's equals to the magnitude of R times the magnitude of V. Let me write V this way, so it's easier to read, times the sine of the angle between the two of them. Now, what is the angle between the two of them? Let me give you two examples. Let's start from the easier one. So I have a circle here, and I have R that goes from here to here, and then I have V that goes from here to here. Now, it's a circle, so they're always going to be perpendicular to each other, so this angle here is always going to be pi over 2. However, when we have an ellipse, they're not always going to be perpendicular to each other. So if this is my R, my V is going to do this. Of course, they're not drawing proportional and stuff, so giving me an angle from the tangential, from a tangent of the ellipse at that point, that is an angle gamma. And this one here is a pi over 2 component. Why? Well, because this one is technically E theta hat, and R is just going to be along ER hat. So these two have to be 90 degrees from each other. So this one has to be 90 degrees. And V has an angle of gamma from the E theta unit vector, E theta vector. Therefore, the angle between the two of them is the sum between these two. So it's going to be, I'm just going to start writing just R and V without the subscript. Technically, it's top, whatever the symbol is on top to understand that it's just magnitude. Anyhow, sine of, we said pi over 2 plus gamma. And this also works if we're on the other side, because if we have on the other side this part here, this is still R, then my velocity vector will be this one here, and it has an angle of, in this case it will be E theta here. This is an angle of gamma here, and the angle between, again, these two will always have to be pi over 2, and so the total angle between these two will be pi over 2 plus the lambda. In this case, lambda is less than 0, so therefore it gives us the angle that is between R and V. But this thing can also be written as RV cosine of gamma. This is just a simple, just a simple trigonometric trig identity. Anyhow, then we have the tangent of gamma is equals to E sine f, true anomaly, divided by 1 plus E cosine f. F is always a true anomaly. This is also equals to, though, because it's a tangent, sine of gamma divided by cosine of gamma. Okay. Now, what we had here, and I'm gonna take it so we can have it here, is RV cosine of gamma. That is equals to H. Now, we're talking about magnitudes here, not vectors anymore. H is also equals to square root of mu times P. Now, I can plug it in, so square root of mu over P, and here I have RV cosine of gamma. And now I said that this thing here is true, right? So I can rewrite this as cosine of gamma is equals to what? Is equals to sine of gamma times 1 plus E cosine of f divided by E sine of f. And so therefore I can plug it in what I had before for cos instead of cosine. Make this a little closer. Okay, so on the left side we had RV cosine of gamma that we now rewrote, and now here we have square root of mu p. Okay, Now, this v times sine of gamma is simply v theta, we said before. So now we have v theta times r times 1 plus e cosine of f divided by e sine of f is equals to square root of mu p. However, we know that our formula r gives us p divided by 1 plus e cosine of f. So let's plug it in here. We have v theta is equals to p times 1 plus e cosine of f times all the rest. So we have everything here. Now these two cancel out, and we're left with v theta times p divided by e sine f is equals to square root of mu p. Let's solve this for v theta, and now we get square root of mu p divided by p times e sine f. Now, on top here, we have square root of p divided by p, and it just ends up being square root of mu over p times e sine f. And here we have v theta. Now for VR, however, we have a similar thing. Now we do have VR here, and we said is equals to v cosine of gamma. um, if we go back here, instead of solving for cosine gamma, we're going to solve for sine gamma. It should work all right, but we can let's see if there's a better way. Um, uh, no, yeah, let's solve for sine gamma. So let's retake this thing here. Let's copy this in here. Let's paste it here. Now we have that sine of theta is equals to uh well, this part here times the cosine of gamma. So now we just have to find a way to plug in this sine of gamma in what we had before. Uh, let's see, do we have a sine gamma? I really can just take that part of there if I want to. But this is a little bit, a step too far. Um, I forgot how to solve it. VR equals to, let's start from directly v cosine alpha. And let's solve again actually for for cosine alpha. So this one, well, we solved it before for cosine alpha. So I'm gonna take what we had before for cosine alpha and plug it in. So this part here. So let's plug this in. And so we have V and VR here. Okay. Now V sine alpha we said before is equals to V theta. Now V theta is equals to what? To this part here. I'm gonna pretty much not cheat, but skip some steps. So it works anyway. So times this part here. So clearly these two cancel out, and we end up left with square root of mu over p times 1 plus e cosine of f. Let's check if both of them make sense with what we wanted to prove. So this is my VR. Let me copy it and see if that's what thought I wanted to prove. Oh, did I think I wrote them in the opposite way. No, Wait, did I cancel out the wrong thing? Uh, Sine of theta. Oh, yeah, I proved v theta again, so it doesn't really help us in our case. But so I actually proved that this was uh, VR and not v theta, and then I proved the opposite. So let me go back and see, did I mess up on this? VR, so if I have my v like this, v vector like this, and this is my angle gamma, then my VR, this is my v theta. I switched them somewhere. Uh, yeah, I switched them somewhere. I'm not sure where, but we do end up getting the two formulas. So if you go back in your notes, you should figure out probably the mistake is somewhere over here. I can't really uh, figure it out. Oh, technically, this one is not here. It's here. It's not a vector. It's a component. Okay. So it's somewhere in here. As you can see, but both formulas come out to be what we wanted. We just have them switched. But I'm sure that the problem lies somewhere very uh, simple.